So the topic for today's office hour is building advanced action levels on action level formulas. And this is part 4 in our 5-part office hour series. The agenda for today is to first look at an existing action level that is, in real life, and then figure out how maybe we might build that using EQuIS. So we'll talk about the available formulas that are in EQuIS for calculated action levels, and then we'll talk about how we would configure the example action level that we'll look at in just a second. So the example that we're looking at is from the National Recommended Water Quality Criteria for Priority Toxic Pollutants, specifically for pentachlorophenol. We're going to be focusing on the freshwater CMC and CCC levels, so the acute as well as the chronic levels. And I do want to mention a quick disclaimer. This is an example and entirely about how to take the word problem out of this example. So if your professional judgment says that you would apply the action level differently or maybe not exactly as demonstrated, then by all means follow that professional judgment. This is really how to configure it based on the information we've got on screen. So I've lifted this particular table from the EPA guidance document. And so we're going to focus on the little piece of the footnote, which I've included in the text below that table, which says that the freshwater aquatic life values for pentachlorophenol are expressed as a function of pH. And they're calculated for the CMC levels as listed there, as well as the CCC, with more or less the same formula, but a slightly different constant at the end of that formula. And we also get a nice hint because it says the values that are presented in the table, the 19 and 15, are corresponding to a pH of 7.8. So knowing that, once we've configured our action level, we can actually test it to see if we're coming up with what this freshwater example is in this table. So if you're unfamiliar with how advanced action level formulas work, we'll just talk specifically about single formulas today. Next week, we're going to talk about the single mixed and multiple mixed. Those are more complex, so we're just going to take one bite of the elephant today. But there are several different kinds of formulas that you can use depending on what kind of action level you're dealing with. And you take a look at the reference calculation that you're using and then maybe can narrow down what particular action level formula you might use. So the 8 formulas that we have available to us, you can see here on screen in this example here. I'm going to turn on my pointer and see if I can highlight some of these guys. So under the Calc method column here, we have listed out all of those 8 individual methods, and then of course the actual calculation in the calculation column. And you'll see that the number of variables varies from formula to formula, but we have up to 5 various variables depending on the formula you select. Now, if you're looking at these and saying, Liz, this still doesn't meet whatever my particular action level requirement might be, we're certainly happy to add additional formulas, but using the order of operations and some of these existing formulas, I think you can get most of the way there with what we already have in our quiver, I guess. So if we're looking for the particular formula for pentachlorophenol, we can take a look at this example here. So we've got our CMC level and CCC. Remember, those are basically the exact same formula. So we'll slow this down a little bit and talk through it a bit more. So first, it's the exponent of a constant times a contingent analyte minus another constant. So we know that we're going to need to look for a formula that includes the exponent function. So if we look down this particular table, we can eliminate 5 of those formulas because none of these 5 include the exponent function. Okay, no exponents in those. We can chuck those out the window. The next thing that we have to consider is that the formula must exclude log because there's no clever way to using other constants basically shade out the log there. So that excludes those next 2 formulas that were remaining. And so all we're left with then is this last one in the table here. So we can see that we're going to have to select the Calc X quad calculation method for this particular formula. Now looking at this, I will grant you that this is a significantly more complex formula than what we're looking at from our reference point. But the beauty of the way that these guys are designed is we're going to be able to use just regular old order of operations stuff that we learned back in probably elementary school to get rid of some of this information. So let's exclude that portion of the calc method formula that's irrelevant to our formula. So remember, our action level for pentachlorophenol is calculated based on the reported value for pH. So we'll take a look at our formula, still exactly the same. We've got our exponent, our constant, our comparative analyte, which in this case is going to be pH, and then our second constant. With this example calculation, we have 5 constants. So there's certainly some that we're going to be able to play with to sort of knock some of this formula out of the way. So let's talk through it. We don't need a plus b. There's no addition part at the beginning of this formula, so we can exclude that. We do need the exponent component. The next section of c times the comparison value raised to the power of 2 isn't going to work because there's nothing in my particular formula that has that second exponent component. And this last section finally is going to match, if I step through it, exactly what the rest of this formula is. So we've got d times the comparison value plus e. So what we're looking at there would be this last part of our formula. So we finally have identified the components of this example calculation. Now we just have to add the variables that will take out the parts we don't want. So what was it? PEMDAS, pick roses, my dear Aunt Sally, to remember your order of operations. Essentially, all you have to do is for the first 3 variables, add those variable pieces of information for variables A, B, and C to exclude them. So variable A would be 0. Because we're not adding anything. Variable B has to be 1 because if we set it as 0, then it would basically knock the entire calculation out, because if you multiply by 0, the answer will be 0. And then again, variable C will be 0 so that we can take care of basically knocking out that entire second part of the equation. So finally, when we get to variables D and E, we get a chance to bring in the 1.005 and the 4.869. However, note that because our reference calculation has an addition function here, that we need to make sure that our variable e is a negative number so that it includes the subtraction component. Okay, so the same will be true for the CCC action level as well. The only thing that will vary is that last variable for our variable e. It's going to be a different value because that's the difference in those 2 equations. So far, so good, I hope. So let's talk about how we're going to apply these to the particular DT action level lookup table. I'm talking about this as though we're populating the EDD because it's really the preferred method for creating advanced action levels. For more information on that, you can check out some of our previous office hours in this whole series. But for now, I'll just talk through just the DT action level lookup. And then when I step out for the demo part of this in a second, we'll talk through the whole EDD. So the first part here, I understand part of the extending part of the table is blurry. That's sort of by design. Ignore that blurry part because we're just focusing on the first part of this table. So the first thing we have to populate is our lookup source, lookup code, and lookup method. And those guys are going to be informed by our action level type, our action level code, and then finally, what exactly we're going to be doing with this data. How are we going to apply this action level? And so in this example, we're using a single formula because our sample pentachlorophenol value or action level value rather will fluctuate based on the available pH data for that given sample. Okay, so we have to say, okay, here is the CAS number for pentachlorophenol, and then also define what our contingent analyte is. In this case, we are still using the CAS number, and since pH doesn't have a specific registered CAS number, in my database, it has pH as our CAS. Okay. So that's the first part of the table. Let's scooch a little bit down with the next part of the table. So we still have the single formula as our lookup method sort to refer back to the last part that we were looking at. And we have our pentachlorophenol CAS number because we're still trying to figure out what the action level is going to be for that. The next part is our comparison ID, still our contingent analyte for pH, that CAS number. The next thing we need to get into is what are we supposed to do with this information? And that's going to be our comparison operator. So for any time that we have a pH value, we want to calculate the action level based on the value of the comparison ID. So we would put calc into the comparison operator field. Also have to include our units for the comparison operator. And notice that the action level field here for anything with a calc is null. That's really important. If you're going to be calculating your action level, make sure that this column is empty, because if you populate it, it won't work. Now, what if you didn't get a pH value for every single pentachlorophenol? I mean, hopefully you did, but sometimes, you can't control everything. So if you have no pH value available, you need to also define what's going to happen. And it sort of depends on how you want to apply that. In this case, I just used the standard action levels that were listed in that table, assuming that the pH was, 7.8, I think. But maybe that's not the way that you would approach this. Maybe you would use a slightly different value depending on your professional judgment. That's fine. If you don't put a pH value in the null row in DT action level lookup, you will get an error in the flag column. And if you don't put a value in the action level column for that row, you'll get an error in the flag column. Okay, so you can always calculate a reasonable action level for the pH for null by assuming a reasonable value for pH and running the equation to calculate the action level. So that's basically what I did in this case. I said 7.8 is pretty reasonable, we'll say. And then so I just used that as our action level reference. Okay. So let's step the last bit down the table here, where we finally get a chance to use the calculation that we determined a few minutes ago. So we're still talking about calculating the action level based on the value of the comparison ID. And so we let our eyes trickle down the rest of this table and see that now, because I said, hey, we're calculating our action level, we follow the bouncing ball and get down to our calculation method. So now we're about to tell EQuIS, hey, this is how I want you to calculate that particular action level. Okay. And then the last part would be defining those individual variables that are present in that calculation for Calc X quad. Okay, so if you remember when we talked through it before, we basically have to cancel out the first three constants because we're basically shading out the parts of the equation that aren't applicable to our actual calculation. And then add in the last two constant fields, the constants that are present in this formula. Okay, so 1.005 and negative 4.869. So you might be saying, all right, that was pretty fast to go through that. And I agree. It took a bit for me to actually get this worked out. In fact, I made a mistake initially in setting up constant 2. I set that to the value of 0. And I had a handy bonus tool that showed me that that was the wrong choice. Okay. So let's back out of this and we'll take a look at an example EDD and my bonus tool that I want to talk about. So the first thing we'll take a look at is the EDD that I used to load into EQuIS. And so, like I said before, it's possible to add all of this information directly to the associated DT action level lookup tables. But I prefer to use the EDD format because, among other things, it checks to make sure that I didn't do something foolish, mistype something or something like that. So there are some additional EDD checks that are nice for sanity. So in the action level table for the action level EDD format, I've got two different action levels that I'm defining, one for the chronic and one for the acute, okay? And I've also defined what my action level type is going to be. In this case, I've got that as an advanced action level type. I want these specifically to apply to groundwater. That's just because these are freshwater limits. And then I do have the remark field populated. And this is a note to me. It doesn't really mean anything else to anyone else. So if you don't want to populate that, that's of course fine. And then the very important thing to make sure you've included is the information in the object name field that's going to tell EQuIS when it goes through to process action levels in the action level exceedance 2 report. Hey, there's more to this. We should go check out the action level lookup table. Okay. So with that piece of information established, the next place we'll go look is action level parameter table. So under action level parameter table, we have to carry over our action level code for the acute and the chronic levels. I also have to say what I'm setting my action level for. So that's the CAS number for pentachlorophenol. just for fun, I've set my exceedance flags differently for each of those values. You can set those to whatever you want. They can be, your standard flags. But when I'm going through and testing these, at least at first, I like to have different flags so I can see how things get applied. And then you'll notice that nothing really else is populated for most of this table until I scooch all the way down to the right of the table. And you'll see the other most important part of this to define is the lookup source, lookup code, and lookup method. So the first thing that the logic for the action level exceedance report does when it hits that DLL that was in the previous table is says, oh, hey, I should go check out action level parameter so that I know what my lookup source, lookup code, and lookup method are. And so the lookup source is going to be your action level type. Your lookup code is going to be your action level code. And then the method, again, is going to be however you're calculating or defining that action level. In this case, it's the single formula. And so if you take a small picture of this in your mind, I'm about to click over to the action level lookup table, and you'll see that the lookup source, lookup code, and lookup method are exactly the same, these first three columns. And so they basically have to match exactly because that's how we're going to carry the logic train over into the next table. In this case, I have two different rows for each of the action level codes, even though it's a single formula. And remember, that's because I had to define not only how to calculate my action level, but also what action level to apply if somebody forgot to sample pH, okay? So this is exactly the same information as we were looking at in our slides. I did want to note that I hid a few of those columns within this EDD for clarity, because the ones that I hid are not applicable to this particular action level configuration. They are important to others though. So in this case, I've got, again, for the calculation, I said, okay, I figured out that it's the Calc X quad, and then I defined my individual constants based on that particular set of values. So if I've got my little cheat sheet here, let me turn it on so that it stays in front of our table here. So we've got our value of 0, 1, and 0, again, to shade out that first part of the equation. And then finally, the 1.005 and negative 4.869, okay? And then same or similar values here for our second calculation, okay? And then again, we also have the action level of 19 and 15, assuming if the pH is 7.8, in case I forget, or in case somebody forgot to perform the pH analysis, okay? So that's essentially how you would set up that EDD. Then of course you go through the create commit process just like usual, and then it's in your database. So let's see what this would look like in EQuIS Professional. So I have my action level exceedance 2 with parameters report up here. I have a specific group that I created for that just includes pentachlorophenol and pH, as well as those two action levels that I defined in that EDD previously. One thing that's really, really important to note, if you're going to be setting up any sort of contingent action level, you need to make sure that you include all of the necessary analytes, because the EQuIS is only going to look at the values that you include in your report. It's not just going to cast out to the database and say, tell me all of the data you have in there. So in this case, my CCC and CMC analyte groups include both pH and pentachlorophenol, so that I have both of those pieces of information to calculate the action levels. So when I run the report, it takes a second to run, even though it's not a very large data set in my testing database, because it does have to go through and math out all of that, right? I've grouped these individual table, or I've grouped the table so that I can maybe separate by action level code and take a look and see how this is actually shaken out. And it looks like I do have a couple of instances where pentachlorophenol did get flagged for my chronic levels, and a couple where it got flagged for my acute levels. So that's good news. I want to show you how it's going to appear in a crosstab report as well. So I went ahead and set this over into a crosstab. And so you can see in this case, I actually have two different rows for pentachlorophenol for each of the collection dates or sample dates for my location. And that's because these are calculated distinctly based on the pH values. You can see they vary across the board because my pH values are very different. And in this last case, we've got a circumstance where we have excuse me, a pH value of a pentachlorophenol action level here of 9.047, on and on and on. And our value that is reported of 10.79 exceeds it. So we've got a flag telling us, hey, it exceeded. So it seems to be working. But if you're not sure, if you want to be doubly sure, we have a bonus tool that I mentioned before. So let me show you what that looks like. So this bonus tool, it sort of looks like an EDD, but it's not. It's actually very specifically not ever to be used as an EDD for several reasons. First, if you're trying to set up any of the single formula action levels based on a calculation, you need to leave the action level field null. But this particular tool, which is available in the materials, or the handouts rather, for this session, allows you to plug in your specific constants that you've defined, as well as whatever your test value is, to see if you're getting to the action level that you're expecting. So in case we forgot the example specifics, remember that value that it first gave us based on a pH of 7.8 is 19 for the CMC value and 15 for CCC, okay? And again, these are our two equations, okay? So back to this table, what I can do here is say, okay, I'm going to take all of my constants that we've defined several times now and put them into the EQuiS calc method here. And then I'm going to put the pH value of 7.8 into my test value. And hopefully we'll get close or exact with the action level field here based on what is presented in that table. So if you recall, constant number 1 was 0. Constant number 2 was 1. Constant number 3 was 0. And then finally we get to the point where we can start defining the constants with those that are actually listed in our formula. So 1.005 and important negative 4.869. Okay. So far it has applied that logic to a value of 100. Well, there's never going to be a pH value of 100. So let's change that to 7.8 and see how that goes. Voila. Okay. So we have a 19.49. It looks like this might have been rounded if maybe somebody else was looking at this calculation differently. But I think it's pretty reasonable to consider that this is a value of 19 and that we were successful in configuring this setup. Remember I mentioned earlier that initially I tried to set constant 2 as a 0. Let's do that. Oops. In doing so, I realized that I managed to just make everything multiply by 0, and so my action level is 0. That's no help, right? So let's also test out the other action level for our CCC value. And so in constant 5, I'll change that negative 4.869 to negative 5.134, and 14.95 rounds nicely to 15. So I think that that has been configured correctly as well. Okay. This is a really handy tool. If you don't get a chance to download this, it's pretty straightforward to create. Essentially what was done here is the calculation that's listed in this table here was created into an Excel formula essentially to reflect that, and then points to each of the constant fields here. But it's a nice gut check to make sure that you've set this up, you know, the way that you're expecting, or that the action level is coming out the way that you're expecting it to based on your configuration. Okay. All right. So just once more to take a look at this, comparing both our calculator and the example that I showed you in EQuiS Professional. So we've got our value of 10.79, and our crosstab report is flagging that, saying, hey, this is outside of our range. So I tried this out in our calculator. I put in a pH value of 7.3, and it calculated our action level to 9.04760, on and on and on. So granted, the number of significant digits in our crosstab is larger than that in our Excel tab, but it's working. We've got it. So we calculated the action level correctly, and it flagged it correctly. So we've got a success. So if you want some more information about this, if you want to have a chance to check out some online documentation, or if you want to look at any of the available recordings that are around from previous sessions, you can certainly do that. I've got those on screen, and in fact, those are also included in the example or in the PDF version of this slide deck in the materials pane. But with that, that brings it to the end of my component of the presentation. So are there any questions? Where are the equations for calc methods stored? Good question. So actually, you can access those from the online documentation article. So let me show you where we can find that. You can either click the question mark in EQuIS, or you can navigate to a particular location in online. So I have that. I can type. It will be the help.earthsoft.com/66/professional. And then to find that, you can come down to the groups and action levels section, advanced action levels, user configured, and then finally formulas. And then if you scroll on down, you can see the description of all of those.
We're not seeing your screen.
Oh, gosh. Thanks, Jim. So there's that groups and action levels to configure advanced action levels, and then formulas and DT action level. And then here's that list of those calculation methods. It looks like Julio asks, for multiple groundwater sampling events, there will be various hardness or pH values available for the calculations. When reporting all available groundwater data, which of the hardness pH values will EQuIS use in the action level calculations? Is there a way to make EQuIS use the most recent value? That's a Jim question.
Right, so it uses the, it matches to the sample. So it's not looking at location to find all the hardness. It's looking at, it matches, it needs to find a hardness or a pH, depending on, or whichever other component you're using in that very sample. So it is theoretically possible to have more than one hardness value for one sample, but that is a very unusual situation. In that case, it takes the first one. If it finds more than one, it takes the first one of the group that it finds.
Ping asks, are the advanced action level features available only to 6.6, or I think it was, do you remember what version it was introduced, Jim?
Well, the original, and so, well, we've had advanced action levels that are hard-coded, and you see in your help page, there's a list of hard-coded advanced action levels. They've been around for quite some time. But the whole point of this was to allow you to configure your advanced action level instead of having to get into code. And we added the DT action level lookup table. We might have added it in 6.5. I think that's correct.
I think that sounds right.
But it was, in 6.5, it didn't have nearly as many. I'm not sure. If we had some formulas, we didn't have this whole list of formulas. So this is, we've been adding functionality to the DT action level lookup, advanced action level, with every version that we put out. So I don't have memorized what 6.5, the difference between 6.5 and 6.6, but we definitely added several formulas. We added the mag sum and the TEQ sum, and we added locations.
Okay.
So yes, you should upgrade to 6.6. One, please.
Allison asks, how do we know which one is the first one with that example in the hardness? Like, how do we know how EQuIS arrived at that first value?
Well, like I say, it's pretty unusual to have more than one hardness for a single sample. And I don't know how, I'm just trying to think of the code in my head without taking the time to look it up, but it looks, it does a search for hardness with the exact same sample parameters, and it creates a tiny table in memory, and then it looks at the first row that comes up. So there's no.
So Allison said that in some cases there are calculated values as well as measured values, but both have the CAS number of hardness. So I think that's probably where that specifically is coming from.
Yeah, I think it's right. And so one of the things, can they both have the exact same CAS RN? That's the other thing. And go into the table. Does the DT result table allow? I think they would have to have a different test ID. But so one of the things that you can do with that, and I've helped a client do it where they had field pH and lab pH. And sometimes, when the field pH was missing, then they wanted to use the lab pH. And we have a whole scheme called multiple lookups that allow you to do multiple lookups. And then if you want to mix looking up and formulas, that would be next week, where we talk about how you can actually mix the two, the function of looking up and the function of calculating.
Yeah, and Julio notes that in the example that Allison mentioned, the analytical method would be different than.
Yes, so you can't just have two exactly the same hardness values in DT result, because it won't let you do that.
All right. Well, Allison says she looks forward to next week. Well, I'm looking forward to it too. It's next on the docket for preparation. So
you better start preparing right now, Liz.
Yesterday, yeah.
It gets a little bit hairy.
It's way more complicated than the one we just talked through today. Yeah. So, but if you have any questions or future topic suggestions, or if you'd like to sign up for future office hours, you can also email us at officehours@earthsoft.com too. So thank you so much, everyone, for your attendance, and hope to see you next week. And thanks, Jim, for joining us to answer stuff I have no idea about.
Well, I didn't have to say a thing till the very end. That was an excellent presentation.
Thank you. Have a great one, everyone.